The goal today, talk about the application reading, and then continue on with chapter 8. I'd like to take, maybe after today, take 1 or 2 more class periods just on chapter 8 before we get into chapter 9. So this was another kind of a pro and con article from Strength and Conditioning Journal. What was your impression of it? Schoenfeld and Williams, pros and cons of deep back squats. So, hi Britt. So as I was reading this article, I think we need to have a definition of what different squat depths would be. Because I think that there's sometimes disagreement or misconception about what exactly is a squat at a certain depth. So I found this one that is consistent with my opinions. As you can see here, this would be consistent with a partial squat. So sometimes this is called a 3/4 squat. This would be a 90-degree squat, which is sometimes confused with a parallel squat. So 90 degrees in this sense would reflect the angle at the knee joint, right here. Sometimes this view would be where the bottom of the thigh is parallel with the ground. So you can see in this case, the bottom of the thigh is approximately parallel with the ground. A parallel squat, you're going just a little bit deeper. So a parallel squat would be where the top of the thigh is parallel to the ground, or even the top of the kneecap is even with the crease of the hip. And then this would be considered a deep squat there, where the crease of the hip is well below the top of the knee. So to define what this article is talking about, we're discussing the pros and cons of this version right here. So I guess talking about the pros to start with. So Schoenfeld, in his segment of the article, talked about the pros of doing a deep back squat. You remember maybe what some of those advantages were? So if you're an actual Olympic weightlifter, so you compete in the sport of Olympic weightlifting, you should probably be doing deep squats, because what's the catch position for the snatch or the clean and jerk? With those heavy weights, it's hard to get those weights very far off the ground before you have to get underneath it and catch it. So for an actual Olympic weightlifter, you have to be comfortable in supporting heavy loads in that deep position, because it's specific to your sport to do that. So taking a broader perspective, Olympic weightlifters do hundreds of squats in a deep position, whether they're catching the bar or just doing a front squat as part of training. How relevant is that to just the average Joe? It's probably not as. So even just an average person, recreational weightlifter, resistance trainer, they can do deep squats, but they're probably not doing near the volume of a competitive weightlifter. So that's an important point that needs to be made, is the deep squat does create greater compression on the patellofemoral joint. So that's the articulation of the patella with the femur. And so because of that greater compression, you can, over time, you can get wear and tear on the cartilage on the back of the patella in front of the femur, which would be a disadvantage. And that's kind of you can kind of tell the background of the different authors in this article. So Schoenfeld is more of a practitioner, whereas the second author is more of a therapist. So you kind of get the contrasting views of each one. The therapist probably sees people with some joint degeneration and so on, so she's taking a more cautious approach in her stance. So from a specificity standpoint, certainly Olympic weightlifters would need to do deep squats. What about other sports? Are there any other sports where athletes are in that deep position as much? Yeah, that's a really good example. So there might be some justification there from a specificity standpoint. So joint angles are super important in creating specificity. I have, maybe not specifically noted in the article, but I have seen some research where deeper squats are associated with higher jump heights over long periods of time. So there could be some evidence that maybe some higher muscle activation, or you train the muscles more effectively with doing a deep squat. What are some other things? So Schoenfeld noted greater muscle activation and development. Okay, so that would have to do with hypertrophy. So getting the most size stimulus would be associated with deep squats. Functional capacity for different sports and so on. Okay, so let's talk about the downside now. So what about the other author? What was her viewpoint? Yeah, so the greater the knee flexion angle, the greater the stress on those cruciate ligaments. So there's more shear stress due to forward movement of the femur on the tibia. So the job of those ligaments is to keep the femur from sliding on the tibial plateau. And so those ligaments would have a lot more stress at the deeper squat angle. What else? Something that she brought up that I thought was interesting is, so we have four muscles that make up the quadricep group, right? So her point was that squats place more emphasis on the bastite muscles. So squat type patterns place more emphasis on the vastus medialis and vastus lateralis. So that's interesting, with lesser emphasis on the rectus femoris. I have seen some research showing that knee extensions place greater emphasis on the rectus femoris with less on the vastus medialis and lateralis. So expanding on her point, we do lots of exercises for different muscle groups because not every exercise for the quadriceps trains the quadriceps in exactly the same way. So there's different emphasis based on body position, foot position, how your feet are rotated, your hip rotation, and so on, can place emphasis on different parts of the quadriceps and other muscles. As a therapist, she's saying that with pre-existing knee issues, so what would be some chronic pre-existing knee issues? Some of the ones she brought up there, sometimes this one's called runner's knee, has to do with patellofemoral cartilage degeneration. It's called, sometimes called chondromalacia. Remember that one? Osteoarthritis, osteochondritis. Didn't even know there was an osteochondritis. I'll have to look up. Anybody know the difference offhand? Osteoarthritis versus osteochondritis?
Something with the cartilage.
Yeah, it has to, with the chondritis, have to be cartilage. So, I don't know, have to look that up. But so her view is if there's someone with pre-existing knee issues, long-term pre-existing knee issues, then you would stick with a shallower squat depth. So her viewpoint was, and her take on the literature was that we don't get any more muscle activation when going beyond maybe here or here. So I guess overall a safe, conservative approach would be, for most people, depending on joint issues, to try and achieve at least this. And if you can improve your mobility, trying to achieve at least that. If you decide to pursue Olympic weightlifting, recreationally even, you're going to have to learn to get here. This takes a lot of glute strength because as you descend below that parallel point, the glutes tend to activate more. So a lot of times people that have a hard time getting into a deep back squat position, you give them hip thrusts for several weeks to strengthen their glutes, and then all of a sudden they're more comfortable getting into that position because their glutes are stronger. So they're able to support that position a little bit better. Okay, so that was that one. Any comments, questions? So as we get closer to exam 2, as we take these applied readings, I'll go ahead and note some things to focus on with the applied reading. And so we'll keep, I like to do the applied stuff because I think that's, you look in the journals and that's where all the timely stuff is at that's going on in the field. So I'd like to take a moment and just emphasize we're in chapter 8 now. So please, if you have access to the textbook, please follow along because there's a lot of great information in this part of the textbook. So written by one of the top collegiate strength and conditioning coaches, Chris Doyle, at the University of Iowa. So this is a textbook put out by this Collegiate Strength and Conditioning Coaches Association. So it's the main textbook that runs the certification for collegiate strength and conditioning coaches. So a lot of good information here. So just want to put a plug in for that. So let's go back to chapter 8. And so when we last left off, we were talking about a couple of different perspectives. So we're talking about a movement-oriented perspective or a movement-oriented mindset versus a muscles-oriented mindset. So a popular saying in the strength and conditioning world is we train movements, not muscles. So we talked all about that in terms of a mindset. The mindset, if we're training muscles, is we divide the body into separate parts, right? So it's more of a, I guess we could say, a bodybuilding style approach. So let's look at that perspective, keeping this in mind, programming based on movement patterns, not individual muscles. So from a a muscle point of view or more of a bodybuilding standpoint, we could call this the muscles mindset, we'll say. And so, as you know, there's lots of different ways of dividing this up, but the key is with the muscles mindset, we are thinking of the body as independent parts, which is a lot different than thinking of the body as a whole and how parts work together to create movement patterns. So I'm going to contrast these two approaches. So it's important that you understand the difference. So, easy example, okay, so day one you might do exercises for your chest and then your back. Okay, so day two, legs and abs. Any of this sounding familiar? Yeah? Okay, what am I leaving out? What parts have I left out?
Shoulders and legs.
Okay, I used to be all about this stuff, so. Shoulders. What do I need? What else do I need?
I have the curls in there.
Yeah. Biceps. Triceps. So, day four is off. And then you repeat. How many are familiar with this type of programming? Okay, so it's a 3 on, 1 off. So day 4 is off, and then you repeat the whole thing all over again. So that's muscles mindset. So we're dividing the body into different parts. So this works really well if the goal is hypertrophy. Okay. What if it's more of a performance-related goal? We want people to jump higher, run faster, perform better as part of their sport. So in some ways, yes, it could benefit, but in other ways, probably not so much. So in other ways, we want more of a movement mindset, which is different. Movement mindset. So we're considering how the body works as a whole with different movement patterns. So once we understand how all of these movement patterns fit together, it becomes relatively easy to design a program because you look at how athletes move as part of their sport, and then you put in different movement patterns to fit how they move as part of their sport. So movement mindset, the goal is different. It's not so much concerned with what your muscles look like as much as functional strength and power is what we're after. So two different things. Now, it is true that you're going to have certain movement patterns that would be included under both approaches. Can you think of an example? So one of our movement patterns is a push. Okay, So a push movement, what's a horizontal push that we talked about from Monday? Like a bench press, right? Barbell bench press would be a great example of a push movement pattern. Okay, so we're thinking of it as a movement pattern, not so much as muscles, which a barbell bench press could fit pretty well right there. But it's a different mindset thinking of it in terms of what do athletes need to do as part of their sport? Do they push as part of their sport versus just building large muscles as a result of doing the movement? So is this making sense as far as the different mindset? Okay, now, of course, taking the movement mindset, you're still, depending on how you program, you're still going to get significant increases in muscle size. But that's kind of secondary to the primary purpose of improving function. So with a movement mindset, you're concerned with how well the program transfers to sports. That's the key. Are we preventing injuries? Is it transferring well to what they're doing as part of their sport? Whereas with this kind of approach, it's okay, muscles are coming first, and then kind of the performance is more of an afterthought. So as far as different times of year, this can be, depending on the sport, this can be a good approach if it's the off season. Okay, off season, higher volume. Some athletes are working on developing greater muscle mass, which can improve body composition. But as we get into preseason and in season, we have to look at more of a movement mindset. So we're not so concerned with building muscle as how movements directly transfer into sports skills is the idea. Okay, so case in point, a couple of different movements compare back squat and leg press on maximal strength and speed strength. I like that word, speed strength. So not just how strong you are, but how fast you can express strength. So we have other terms for that, like rate of force development, power development. These are key characteristics for success in sports. So looking at a couple of different exercises, you would assume that a back squat probably has a little more of a movement mindset versus, say, a leg press, which would be more of a muscles mindset. Leg presses are great if you want great big quadriceps. They work really well. You can really load up the machine and get a good quadricep workout. But with back squat, you're getting a lot more benefits in terms of core stability, because on a leg press, the machine is pretty much doing the stability part for you, and you just have to provide the driving force to push and lower the weight. So there's a whole bunch more benefit with back squat in terms of this movement specificity. So looking at the course of 10 weeks, so time 1 versus time 2, and so those that trained with a back squat versus those that did a leg press, looking at their squat jump performance and their counter movement jump performance. So how many by the show of hands have done both types of jumps? Yeah. So a squat jump is, you're just taking the pre-stretch out. So you squat down and then you hold it, and you let all that elasticity dissipate, and then you push off from the floor. Whereas a counter movement is just like you normally jump. It's a quick load and then a takeoff. So we can see the percent difference here. Control group, not much, which you would expect. They didn't do any training. But you can see with the squat, the percent increase in performance there for at the end versus the leg press group. Counter movement jump, percent change versus leg press there. So just to reinforce how important it is, if we're working on sports-related skills, that we take a movement mindset versus just muscles. Okay, all right, so correcting faulty movement patterns. This is an important aspect of performance because not everyone moves most efficiently. So efficient movement is really important because we conserve energy, right? Energy conservation is a huge aspect of sports. So Ashley has a 90-minute soccer match. So energy conservation is a key factor. Fatigue resistance. So we want to teach correct movement patterns. Sometimes, unfortunately, misapplication of this approach can lead to severe dysfunctional movement patterns. So we overdo it on training and attempting to gain hypertrophy in some muscles, which throws our entire body out of balance to where we're no longer moving efficiently. So joints are not under equal amounts of stress on each side of the body. So corrective work, and we'll talk about a lot of this corrective work as we get into I call it a lab, but we'll just be in the weight room doing stuff later in the semester. But some examples, a squat with limited ankle mobility. So how many of you have ever thought that limited squat depth could be due to a limitation in ankle mobility? That's an interesting thought. We improve our ankle mobility and all of a sudden we can squat deeper. So it may not be an issue with the hips, it may be further down the genetic chain. If we can learn to dorsiflex at the ankle, we can squat just a little deeper. Push-up with limited core stability. And that can be an issue. Overhead squat with limited shoulder mobility. You can tell a lot about a person and how functional they are simply with just an overhead squat assessment. You can get so much information and so much benefit from doing overhead squats. I like to include those for lots of different athletic groups just because it's a total body movement. We're not concerned with the body in parts. We're considering the whole body working together. And so if there's any deficits in mobility or stability, you can see it immediately with an overhead squat. So here's an example. Picture's a little blurry there, but this would be an example where we have great ankle mobility, and so that would contribute to achieving better squat depth. So you notice here the posture is more upright. The ankle has more dorsiflexion in this example. So what if dorsiflexion at the ankle is limited like this? So if we have a limitation in one part of the body, what does your body attempt to do to make up for it? Compensate. That's a good word. Compensates. Compensates. And that's exactly what happens. So if you know that you have to achieve at least parallel or below in your squat depth, and your ankles won't allow that to occur, you're going to try to compensate for that with a little bit more lean at the torso. And a lot of times in extreme examples, you'll lose your neutral pelvis, and the pelvis will tip back. So the pelvis will actually tuck underneath. How many have heard of that concept? What's the, what do we call that? Yeah, butt wink is the informal gym term for that. So if we can correct this ankle mobility, then our squat technique can improve. So how do we do that? Yes, Nolan.
I have a question.
Sure.
So in some cases, if someone does have a butt wink and they're able to get really, really low, like the lady on the left, what is that kind of indication?
So if they have the, I guess I'd go ahead and explain more.
So when they're in a deep squat, their pelvis still does the wing action, I guess. What would that kind of be?
Well, we would want to go to the point just before that happens. Because as soon as that starts to go back, that means the lumbar spine is going to go from extended to flexed, and then the discs are under a lot more stress. So over time, you would want to gradually, with mobility work, try to increase that depth without tilting back. So any tilt underneath is not, wouldn't be considered a good thing. So you want to try and gradually increase mobility to where you can get that depth without the pelvis tucking or tilting back. So how do we improve that? This is already one thing that we talked about. So it's just mobilizing the ankle joint. And so you'd want to place this band. You can't really tell exactly where that band is, but you want to make sure it's underneath the malleoli. When you do that, what are the malleoli of the ankle? That's those bumps, those bony processes on the side. You want to make sure that band is applying pressure underneath. So if the band is too high, it's not going to do any good. So we want to get right into that articulation between the tibia and the talus, which is just underneath the malleoli. Here's another one where you're actually putting just a little bit of weight on the knee joint to get into that dorsiflex position just a little bit more. So this is just one strategy. There can be other things to do with the hips, and so as we meet in lab, we're going to go through a more complete assessment of things that can be going on. So push-ups. Okay, so everybody does push-ups. But with limited core stability, you immediately notice a lack of postural alignment. So I like to think of core stability in terms of postural alignment. It's this ability to brace that creates a stable center in your body, and then everything up and down, above and below that point has better alignment if we're more stable in the center. So how do we correct that? So this is one that I like to program for that. It's called an overhead polyp press. How many have done similar? So there's all kinds of polyp press. Essentially, a polyp press is just resisted rotation. So your torso is resisting movement through different planes. So in this case, he's got a rope attachment in a kneeling stance here. The cable is behind, and you think, okay, well he's going to do an abdominal crunch. Not in this case. What he's going to do is he's going to slowly raise his arms like this. So as he's raising his arms, what's going to happen if he relaxes here? He's going to go back this way, right? Which you don't want to do that. You want to keep everything in nice alignment. So you're tightening here, creating greater stability, which would help you with that push-up posture, and then you're just slowly up and down like that. So this is what we call an anti-extension exercise, because if you release your core stability, you're going to extend. So it's anti-extension. So we can do all types of anti-rotation exercises through different planes. Okay, so a few pictures here. So this would be an overhead squat with limited shoulder mobility. There's actually quite a bit of issues. So ankle, hip. So there's a lot of things going on here. So one of the things would be shoulder mobility. So can you imagine trying an overhead squat with an actual standard 45-pound barbell versus we typically start with a dowel rod? So that'd be really hard to hold up there, wouldn't it? In that position, where do you want that weight with an overhead squat? Yeah, you want it aligned right from the top all the way down through the center of the foot like that. So one of the limitations can be our ability to downwardly rotate and retract the scapula. So we want the scapula to swing down and in a little bit to keep the weight in alignment above our bodies. So if this tends to happen if you're overdoing it on this stuff. So the pecs and the lats, and you overdo it on a lot of that. Over time, that can result in this type of dysfunction because both your chest and your lats pull your arms forward and into internal rotation, which makes it difficult to bring your arms back during an overhead squat. So just a couple of correctives here. So this would be an incline shoulder wide. How many have done similar? So we're just, you can just see, you just want to take this person and put them over here, have them doing some incline wides to train those muscles. And then for the flexibility portion, just a doorway stretch works pretty good as well. So just a couple examples here. So just trying to get you into mindset, moving from this approach over to this approach. So it kind of depends on your goals, but even if your goal is muscles, you can still be balanced in your development. You can still be functional. So if your goal, if the only goal that you have is to get large muscles, there's no reason you can't still have functional movement patterns. There's no reason your body can't still have adequate stability and flexibility and so on. Okay, so balance development is critical. We did the band pull aparts as an example on Monday. So program designed for strength and power. So let's review these: functional, strength, and power. So our first category, and we're not including all of these categories in every single workout. So we're going to go over categories and then we're going to shift to examples of program design. So our ground-based explosive power movements. What does OWL stand for again? Yeah, so those are our Olympic weightlifting variations. So this can also include any and all variations of Olympic weightlifting movements. So both arms, one leg, two legs, everything, single arm, and so on. This category, because it has a very high neurological demand, this would also include ballistic, explosive type things like jumps, footwork, agility drills. Those things would go right at the very top. So when you're not fatigued, when you're able to put forth 100% quality effort on each repetition, that would be right here at the top. So number 2 would be our lower body. Okay, now the author divides the lower body. We talked about squat patterns and hip hinge patterns. So the author puts both of those under lower body movement. So a knee dominant lower body push. This would be where all your squat movement patterns go. So it doesn't matter what it is. Anything that relates to a squat movement pattern, off 2 feet, off 1 foot, step ups, lunges, pistol squats, step downs, lots of different variations. That would go under this category, squat movement patterns, knee dominant lower body push. Okay, so the other category, hip dominant, lower body pull or push. So this would be all of your deadlift variations. Okay, RDLs, also called stiff-legged deadlift. Anything that involves a hip hinge. Hip dominant would be here. Hip thrusts would also be in this category. All variations of hip thrusts, hip bridges, and so on. Okay, so next would be your upper body. So under this category, horizontal, vertical, diagonal, you've got your pushes and your pulls. So push and pull. We want to try and develop somewhat equal strength. Our ability to push and our ability to pull. Because we have opposing muscle groups who want equal stress on the shoulder. Okay, so the fourth category would be the torso or the core, and we'll look at some examples there in just a moment. So those are a summary of our movements that we'll put together into a program. And then 5 would be your auxiliaries. So sometimes these are associated with muscle imbalances, okay, or weak links. So you look at your body, where do you have a weak link? That would be where you put it right at the end there to strengthen the weak link in the kinetic chain. Okay, so table 8.3 from your textbook. So basically what we just talked about with some examples listed here. Explosive ground-based power movements, Olympic variations, jumps, throws, lower body push, knee dominant. Okay, so this would be where all your squat variations, single leg variations, so single leg step up, split squat, lunge, Bulgarian split squat, single leg free squat. So any squat variation you can think of would be here. Lower body hip dominant. Okay, so all of your deadlift and bridge hip thrust variations would go here. Upper body press and upper body pull, and then the torso. So I enlarged the part for the torso because there's a few things that I want to talk about. We talked about resisted extension. There's also some other movement patterns that we can resist. So a traditional Pollock press, you have a cable or a band out to the side here. So it's coming this way, and then you're doing this. So if I relax my core, where am I going to go? I'm going to rotate this way, so it's anti-rotation. Very important for sports, anti-rotation movements. So your planks are all here. It's hard to list every single variation that exists, but anterior chain fallout variations, that's an interesting one. Anterior chain fallout variations. Anybody know what that is? I'll bet you will once I put a picture up here. So how many have done an ab roller? That's an anterior chain fallout variation. So as you roll, or we could say fall out, what tends to happen in the center of your body here? It's more demanding, more activated, or at least it should, as the movement travels further from the center of your body. So that's what an anterior chain fallout variation looks like. This would be a variation of a polyp press. So resisting rotation in a half kneeling stance. You can see the cable is here. And so you can just hold it here for a period of time, or you can press like this. So you can make it both dynamic or isometric, depending on how you choose to do the movement. So as you go further away from your body, what should happen with your activity? It should go up, because the mass is further away from your muscles that are working. So, all right, so let's get into 2, 3, and 4 day example programs. Taking a movement mindset with our different movement categories. So this is an example of a 2-day program. So say day 1 is Monday, day 2 is Thursday. So if all the time you have is 2 days, and maybe 45 minutes to an hour each of those days, it can be challenging to figure out what to include. So you really have to prioritize in your mind what's the most important parts. So I want you to notice here, so on Monday we have A1 and A2. So notice how everything is prioritized. So we're going from A1 all the way down to C3. On the other day, it's the same way. So A1 all the way down to C3. So that indicates the priority. It's not that the exercises at the bottom aren't important, but it's relative importance. So you would place the most important things at the top. So A1 and A2. So we're pairing an explosive exercise. That could be an Olympic weightlifting type exercise with a mobility exercise. So the PR here means pair. So they're paired together. So you do a set of whatever the explosive exercise is that you put in there, and then you go to a mobility exercise. So that might be some type of foam rolling exercise that you would put in with your Olympic lift. B1, B2, and B3. So now you're pairing 3 exercises together. So do you notice with this approach, it's very time efficient? So if you only have an hour twice a week, that's not very long. So efficiency is important. And what if you have, say, 20 athletes in a small room all together with limited amount of equipment? You have to be very efficient. You have no choice. So you have to pair things together to get the most benefit in the least amount of time. So lower body push, knee dominant, that could be a squat, a lunge, or a step up. So you can go back to the previous slide and take a look at what your knee dominant push exercises are. Pair with torso stability. So that could be some type of plank or a polyp press. In that category, pair with a vertical pull. So the author listed here a pull-up variation for this category. Okay, so then we get to C. So again, 3 exercises that are paired together. So single leg, hip dominant, emphasis on posterior chain. How many have heard that word, posterior chain? So you're talking about everything down the back side of the body, all the way from the base of your skull, all the way down to the soles of your feet on the back side, all the extensor muscles. C2, torso, anterior chain, okay, so the front, and then C3, vertical upper body push or press. Okay, so any questions on how that works together? So you'd want to go, you would program a certain number of rounds for each of these groups. Each of these segments, you would program a certain number of rounds or sets to go through each one. So Thursday then, again, explosive paired with mobility. Okay, and then B1, B2, B3, horizontal upper body press. So some type of bench variation paired with a torso rotation, paired with a double leg hip dominant. So probably some type of deadlift or stiff-legged deadlift, RDL type exercise. And then all the way down here, single leg lower body push. So single leg variation there, torso stability and horizontal pull. So any of your row variations would be a horizontal pull exercise. So that's just an example of a very efficient 2-day-a-week program with the movement mindset. So it was hard to fit on the slides. You can take a look in the textbook, but here's what, if you be given 3 days to work with a group, this is an example. Again, the priorities are in there, A1 through C3, all 3 days, putting together different categories. And then this is your 4 days. So if you're blessed to have 4 days with a group, which would be great, you can really expand and do some additional things there. So I can't emphasize it enough. Get into your textbook, look through these tables, learn about these categories. Do you have any questions at this point? So it's really different. Coming into this class, I'll bet most of you are probably familiar with this type of stuff. Maybe not as familiar with this type of stuff. So more and more, if you look at strength and conditioning, it's moving towards more of this functional mindset, the body working together in general movement patterns versus isolated parts. Okay, so specificity. So what are some things that you would consider important for specificity? Yeah, what they do as part of their sport. It's important. So visual movement similarity. So 100% specificity is very difficult to put them into a movement with the same load and so on as they would encounter in the sport, but we can make it as similar as possible. So the neural recruitment pattern might be different, but we try to do exercises that simulate what they're doing in their sport. Okay, so part of that would be joint angles, muscle actions, concentric, eccentric, isometric, and so on. Movement speed. So that's especially important this time of year. So especially when athletes are in season. So as an example, Nolan and his team are in season, so we're doing a lot of speed squats right now. So we put some bands on the bar. This morning they're doing a lot of speed squats with emphasis on the load at the top of the movement. How many put bands on a bar and done squats? Rubber bands on a bar. Maybe we'll do that next week. So the band tension is less at the bottom, and then as you come up, what happens to the bands? They stretch, which creates greater load. That's the part of the movement where you have more advantage anyway. So we're taking the load off at the bottom to take a lot of the torque off the back, and then we're increasing the load at the top. So the acceleration is greater with a banded speed squat versus just a traditional squat. So movement speed is really important. Getting that triple extension, which is what we get with Olympic weightlifting variations. So fast extension of the hip, the knee, and the ankle. So we find that there's a significant correlation between Olympic weightlifting movements and your ability to jump and sprint. So over time, you would want to include those because if an athlete needs to run fast and jump high, you got to be including those lifts that have similar characteristics. So ground-based movements are important. So we need to discuss what's the difference between an open chain versus a closed chain movement. Open chain. So the body is a kinetic chain. So a series of bony segments that are linked by joints. So an open chain movement means that the feet are not in contact with the ground. So a leg extension or a leg curl. Whereas a closed chain movement means that the feet are fixed to the ground. So ground-based movements would be closed chain movements. The feet are fixed to the ground. So it's thought that closed chain movements are more transferable to sports. That makes sense. Multiple joints, lots of muscle mass, or coordination and stability. So they're more transferable versus seated or lying down. So you may be asking, well, one thing we haven't talked about is instability devices. So where do those exercises fit in? So doing some type of squat or deadlift on an instability device. So what are some instability devices? Yeah, both BOSU. So how many of you have seen it's a black platform with kind of a half hemispherical type, looks like a physio ball cut in half. So everybody know what that is. Okay, so how do we fit those in? So the current perspective is programming unstable days rather than quote unquote light days. So if you have one day a week where you're doing a lot of ground-based, heavy, high velocity type lifts, maybe the second day of the week you do movements with lighter weight, but maybe putting some of those movements on an unstable surface. So that way you're hitting all your bases. So what is the additional benefit of doing an exercise on an unstable surface? Why do we use unstable surfaces? What's your thoughts on that? Okay, good. Okay, so we may be bringing in additional muscle activity that may not be present with just a ground-based heavy lift. Okay, that could be true. What else?
Just different activations of muscles as well.
Yes, so different neural activation patterns, which is really important. So sometimes we might be playing on maybe not an unstable surface to the same extent as a BOSU, but an unstable, relatively unstable surface, which would fit the specificity requirements there. Where else might we be getting a little more activity on an unstable surface? Core. Our core tends to get a little more activity. So we have to keep everything in perspective, though. We can't think that more instability is always better. Some instability is good and is a piece of the program, but more instability isn't always better. In fact, trying to find a way to make everything you do more unstable can have a downside to it. What do you think that downside is? Say again?
Lower limb responsibility.
Yeah, the lower load is one thing. So if you're trying to develop maximal strength in a functional position, extremely unstable positions can reduce the load. What happens to your movement speed a lot of times? It's going to be less because you're more cautious on an unstable surface. So the unstable surfaces are good, but we also need to make sure we're doing enough ground-based exercises where we can maximize force and power output. So I want to go through just a couple examples. So another key benefit of training on unstable surfaces is we get what I like to call joint protective responses. Joint protective responses. That's a good thing to have. So what that means is we're getting co-contraction of muscles on both sides of a joint. So to protect the joint, we want muscles that surround the joint to be activated. So if muscles on both sides of the joint are activated, that joint is more stable. It's not as mobile. It's protected. So from an injury prevention standpoint, that's a good thing. So doing exercises on unstable surfaces could have a relationship with reducing risk for injury because of that co-contraction, joint protective response. However, if the goal is to maximize strength and power, you need to move away from instability and get into a ground-based position where you can maximize force. And so let's talk about this study from Cressy. How many have heard of Eric Cressy? I'll bet baseball players have. So he did his master's thesis at the University of Connecticut back in 2007. And he published that. And so here's his results. So he did a really creative study. So what he did is have two groups of athletes do all their exercises with increasing instability for 10 weeks. He had another group of athletes do traditional ground-based exercises. So the objective of his study was to determine how those different approaches affected measures of sprint speed and jump power. So he wasn't looking so much at reducing risk for injury as much as just how do you make them faster, how do you make them jump better. So what you're seeing here, the two bars, the two green bars, the pre-test and the post-test. So before and after 10 weeks. So you have the depth jump test. How many have done depth jumps? So you drop off of a box, and then you hit the ground, you contact the ground, and then you have another box that you jump up onto. So you want to quickly get off the ground and onto the next box. So he did a depth jump test, and then he also did a counter movement jump test. So in each case, what you see here, the results for the group that trained mostly on unstable equipment versus the group that just did traditional ground-based, feet in contact with the ground. And so you can see the unstable group here, their depth jump performance went up a little bit, okay, which is good, okay. The group that did the ground-based training, their depth jump went up quite a bit more, okay. From a counter movement jump standpoint, the group that did most of their training on unstable surfaces, you can see not much change in counter movement jump performance. Group that did mostly ground-based, there was pretty good change there in terms of their watts. What is watts an expression of? For those that haven't had biomechanics. Watts, mechanical watts is how we express power, right? That's power. So the more power with these types of jumps. So what about 40-yard speed? That's an important measure, especially we've got the NFL Combine. I'm not sure if these were football players or not, I'll have to look. But 40-yard speed. So the group that trained for this 10 weeks, mostly on unstable equipment. You see a disturbing trend here? Okay, so they're getting a little bit faster, okay? But the group that kept their feet on stable ground, they're getting a whole lot faster post-test. So what's the take-home message? Is instability training the be-all, end-all? It's important, but the timing of training is a key factor. So yes, we can train on unstable surfaces, but probably not year-round. So if you're working into a phase where you need to be just as strong and as powerful as possible, you probably want to stay off unstable equipment. If you're in the off-season or early preseason or maybe rehabilitating from an injury, then sure, unstable equipment would be good because you're developing that joint protective response. So the timing of your training mode is really important. So here's just some other stuff to promote why ground-based training is so important if the goal is strength and power. So Bain in 2002, maximal external force output of the leg extension plantar flexor muscles decreased 70.5% and 20.2% when performed on a physio ball versus a stable bench respectively. Another one here, external force output of the pectoralis major decreased 60% when the chest press was performed on a physio ball versus a stable bench. Okay, McBride in 2006, maximal external force output and rate of force development, that's really important, decreased 45.6% and 40.5% when squats were performed on balanced discs versus the ground. And then Drinkwater in 2007. How would you like to have that last name? Drinkwater. I've actually met Eric Drinkwater. He and I have done a couple papers together. Ground-based free weight squat versus a BOSU free weight squat with a 10 rep max load. So the same load, different surfaces. Look at the reduction here. The BOSU condition decreased concentric power, concentric force, concentric velocity, squat depth, and eccentric power. So just trying to get the message across that instability training is great and it's important, but not during training phases where maximal strength and power are the focus. Okay, so specificity, we want multi-joint compound movements. Compound movements, meaning we have a coordinated action of muscles over multiple joints. I think sometimes we just underestimate how important the basics of weight training are. So sometimes I walk in the weight room and I see just an abundance of single joint exercises. I think sometimes we just underestimate that we really don't need a lot of movements. Just a basic squat, a basic press, a basic pull, and maybe a little bit of targeted core stability, and that's really a total body workout. I think we need to spend more time on just getting better at pressing, better at pulling, better at squatting, better at stabilizing, versus focusing so much on just these isolation type movements. If you look at, how many have looked at strongman type training? Okay, I mean just all of that, that's the essence of compound movements. But what are those guys, what do their muscles look like? Huge, right? And I would assume that they're not spending a lot of time on just single joint bicep, tricep. It's all compound, big squats, deadlifts, presses, pulls, and so on. So neuromuscular recruitment patterns that are similar to what we're doing in the sport. So when should we include single joint exercises? Those are good for auxiliary movements. Okay, so I keep bringing up baseball. But baseball does a lot of auxiliary movements for shoulders. A lot of external rotation, a lot of Ys, Ts, Is, those types of patterns with your arm. So we call them letters, Ys, Is, and Ts, and so on. So a lot of people have really weak hamstrings. So we can do a targeted movement to increase hamstring strength to reduce the risk of knee injuries. So there's a place for it. I'm not saying don't do it, but specifically if there's a weak link, if your compound movements are suffering because you have a weak link, then you need to target that weak link. Like what Steven said with tricep extensions to improve your bench press performance. So more and more I like to think of single joint movements as weak link movements. Movement through multiple planes. Okay, so we're getting sagittal, frontal, transverse, diagonal. I think too often we place emphasis on just the sagittal plane, so flexion and extension. But I think the transverse plane a lot of times gets neglected, but think how often athletes rotate or resist rotation. So transverse plane movement is really important, should be a priority. So let's end off here with power. So power is defined as the rate of doing work. So how far we can move our bodies in a given amount of time. More movement over less time means more power. So to have high power output, we need to have a high rate of force development. So we develop that by moving fast. So very important point. If an athlete always trains slow, they will stay slow or become slow. So as we progress from off-season to pre-season to in-season, we gradually need to increase our movement speed. Lifting heavy weights and getting that muscle pump can be really a fun part of training, but over time, if we want to become faster, we have to move away from the heavy weights and understand the other side of power is velocity. So moving fast. If we move fast in training, then we can become fast or improve the speed that we already have. So even when we lift heavy weights, the intent should be to move fast. Even though the actual velocity will be slow, even when we're working with a heavy load, the intention in our minds is to move it fast. Okay, so we'll end off here. We'll talk about Harris on after spring break, Monday after spring break. So are there any questions? Okay, all right, thank you and have a wonderful, safe spring break.